All right. So now let's get started. So tonight's webinar, we are super excited to have Kim Rimby with us. Kim is an author, inventor, entrepreneur, speaker, consultant, coach, mentor, advocate, and most of all, I think you'll find this out tonight. One of the things that she's most proud of is that she is a teacher. She currently serves as the Chief Learning Officer and CEO at KP Mathematics, and she is an official Building Thinking Classrooms consultant alongside with Peter Lillenjahl. I probably said his name incorrectly, so I should have apologized in advance. Like I said, she's a lifelong teacher and learner, and really, having known Kim for a number of years, her heart's work centers on making sure that teachers have what they need and helping them see the beauty of mathematics and fall in love with teaching and learning all over again. So with that, Kim, I am going to stop sharing my screen and let you take over. And there you go.
Okay, so just want to make sure everyone can see my screen.
Yes, you
And
are good.
excellent. Hello, everybody. And thank you so much for spending the afternoon, evening, morning, wherever you are in the world. Thank you for spending this hour with us. We are so excited to just be able to talk a little bit about math. And as the title of this says, we're seeing the math. We want to see the math come alive, which goes along with this little book that I recently wrote called Seeing the Math You Teach. And it's a book that we wrote through Corwin just to support teachers with all the different ways that we can represent mathematics in a lot of different ways. And one thing that happened is when Mark and John and Jeff and everyone over there at Brainingcamp saw this book, we were seeing this really great connection between the ways that we want to help kids visualize math and the way they can do so with Brainingcamp. So that is why we're here together, just like peanut butter and jelly. We wanted to put these two things together. And one thing that I want to make sure you know, now that we're all getting started here, is that we are really going to be covering the gamut from kindergarten up through high school. Just looking at some common models. I'm a firm believer that no matter what you teach, knowing what comes before and goes after the mathematics that you teach changes the way you teach math. And so today we're going to be talking about these topics, just different ways to represent mathematical thinking. We're really going to look at that continuum across the grades as we use this area model, starting from the 10 frame all the way up to using the area model for algebra. So everything in between. So hang in there and just know that no matter what grade level you teach, no matter which kids you work with, knowing what happens before and after your grade level can make all the difference in helping your kids really see the math that you're teaching and the math that they're learning. And then finally, we will make those connections across the grade levels. So what I'd like to do to get started is just have everyone head over to the chat box. I have it open so I can see what you're putting in there. And what I'd love to know is, what are all the math tools that you think should be in every math class? And so this is just a blast. Just put as many ideas as you can think of. It's going to go really fast. But what are all the math tools that our kids should have access to in the classroom? I'm seeing lots of number lines and algebra tiles, fraction pieces, arrays, reckon recs, base 10 blocks. Keep going. Ooh, counters. I have something to say about counters. Rods. I'm wondering why rods are we talking about base 10 blocks or Cuisinart rods? Right, popsicle sticks, good one. That's Peter Liljedahl's favorite. Hundreds charts. Well, the name of the book was Sing the Math You Teach. We'll show it to you again in a little bit. Oh, look at that. They have Brainingcamp in the list, guys. Nice job. Reckon Rex. So, yes, all kinds of tools. And I'm seeing kind of a nice balance. Ooh, number balance. That's also one of my favorites. Manipulatives, all kinds, both physical and virtual. That is obviously going to be something that we're going to be talking about today. I just saw paper. Some of my favorite manipulatives when I'm working with fractions is literally paper folding and cutting and having kids create their own fraction pieces. So, and then we've got some visuals, some graph charts, bar models, grid paper, bar diagrams. So, great list. Now, one thing that I noticed, I'm still watching, so don't stop if you still have more ideas. One thing that I want to just make a note of is this idea of counters. This applies to everyone in here. Is a lot of times, I'm sorry, I just saw Play-Doh. That one made me smile. One thing that it's really important to realize with counters is that back in the day when I taught kindergarten, now you have to know I really do run the gamut kindergarten through calculus with the teachers I work with. But back in the day when I was teaching kindergarten, I had every counter you could imagine. I had teddy bear counters, car counters, people counters, Christmas tree counters, heart counters, pumpkins, shamrocks, you name it, every possible counter out there. Oriental Trading Company was my friend, all those little erasers that they sell. And it turns out that many years later, not so long ago, I found out that it's actually better to just have one or two counters, like maybe some discs, maybe some two color counters, because and they turn into integer chips when we get to middle school. But just having a couple of counters rather than all those different ones. And today we're going to pretend these counters are teddy bears. And tomorrow we're going to pretend that they're cars. And then we'll pretend that they're people and they're cats and they're trees and they're hearts. And the reason for that is that actually triggers the same part of the brain that we're going to use later on when we have the value of x is 2, or the value of x is 1/2, or the value of x is negative 200. So teaching the kids to be flexible with the counters and the pretending in the early grades supports the thinking they're going to use later on when they get into working with variables and into algebra. So, just my little side note about counters. But with all those math tools that you all listed, I actually made some lists on the screen as well. And the first thing I'm wondering is how many of you saw some tools that look like these, right? Counters, pattern blocks, snap cubes, base 10 pieces, integer chips, algebra tiles, unit cubes, all those kinds of tools, right? I think we hit that list pretty well. And then here's another list would be number lines, 10 frames, place value tables, tape diagrams, bar diagrams, ratio tables, hundreds charts, multiplication and addition charts. Those also are tools that our kids need access to. And then we just have the regular numbers, all the symbols, the operation symbols, the equality and inequality symbols, calculators, cards and dice, right? That's a whole other group of tools our kids need access to. And then I'm sure it was out there, I just didn't see it, but we also want to make sure we have tools like anchor charts and sentence starters, discussions and writing, different kinds of paper. I saw that, different kinds of writing tools. And then finally, we also want to have coins, clocks, measurement tools, math stories, just different kinds of tools that fit into that bucket. So there are a lot of different kinds of tools, and by no means did I even come close to listing all of the things that you have on this list. The last thing I see there right now is balance scales, which would fit with our measurement tools, right? So we have all these different kinds of tools we want kids to have access to, both physical and virtual when it comes to the manipulatives. So I'm going to just leave that for a second and just address this issue right here, because most of us somewhere along our teacher learning time heard about this concrete pictorial abstract framework. And for me, I learned about it through Piaget's work. But very often, when we look at this, we think of first, we want the kids to have something concrete, right? Something three-dimensional. And then we put it away, and then we can start doing drawing pictures and drawing number lines and bar graphs and working with different types of visuals. And then we shift into having them work with numbers and symbols and equality symbols and so forth. So going from concrete to pictorial abstract, a lot of times we think of this as a pathway. That's how a lot of us were taught. And honestly, a lot of our textbooks even have progression set up this way. And yet, this is not what was ever intended. What was actually intended is that we have the concrete, we have the pictorial, we have the abstract. We have these three different ways of representing mathematical thinking, and they interact with each other. The important thing here is these arrows that our kids connect the physical tools to the concrete tools to the visual tools and the visual tools to the abstract tools, and that they're seeing how these things connect. I want them to be able to see how these things work together, as opposed to I master something with concrete and then I get out the pictorial, but I don't ever see how they connect, or I don't see how that corresponds with what's going on in the abstract. So that connection is really important. And to take it even further, more recently, we've had this lush translation model, which you can see up towards the top, the physical, visual, symbolic, that corresponds with concrete, pictorial, abstract, right? And you can see that they're all interconnected here. They all have arrows going back and forth. And then we've also added the verbal representations. So we want kids to be able to talk about math, to explain their thinking, either verbally or in writing. And then we also want kids to be able to contextualize mathematics. Now, most traditionally, the contextualization sounds and looks like word problems. But the truth is, often I want the kids to be assigning context. For example, I might put something up on the board like 95 divided by 4, just something abstract. And I'll say to the students, now I want you to tell me what's a context that could go with this? What could this be describing? I did that with some fourth graders not too long ago. And one student said, oh, that could be 95 hair ribbons shared equally with four sisters. Someone else said, ooh, that could be 95 soccer balls put equally into four bins. A third child said, well, that could be 95 carrots shared equally among four friends. And I thought, carrots? Fourth graders? I'm not sure where that context came from, maybe just after lunch. But what was powerful with this was that they were the ones making sense of the math. They were understanding that math helps us describe the world around us and to solve problems. So that contextual is a really important idea, not only for us to be ascribing context to the math, but for the kids to be doing that as well. So, these are the five different ways that mathematics can be represented. So, now let's go back to those lists that we were making a moment ago. And you see how I have those organized. That's just a sampling, just an example of the different types of representations and models students can use. Now, remember what we were talking about a moment ago. The most important thing here is the arrows. Those five buckets are important. We want kids to be able to share their thinking, to represent their thinking in many different ways. But we want them to be able to connect what they did with the physical tools with what they're doing with the visual tools, and what they're doing with the physical and visual tools with the symbolic tools, and being able to describe it and talk about it as well as contextualize it all along. So those connections are what's important here. And we're going to be talking about that a lot today as we go through the examples of the area model. So, just for those of you who this might be new for, I know a lot of us have heard about the Lush translation model most recently, but I also included a couple of different options for you. This is something I actually share with students. And I talk to students about how they have options to be able to show their thinking. And in any given lesson, I might be teaching a lesson on decimal division. And I'll have some students who will grab some manipulatives. Some students are going to hop onto Brainingcamp. I'll have some students who are going to use the grids that are in the books and just do some coloring with those. Some students who might go straight to numbers, right? So I want them to know that they have options when it comes to representing their thinking. We all have many pathways of getting there. So here are just a couple that I snagged off the internet. Feel free to snag them from me and share them with the students that you work with. So now we're going to just make a little shift here into talking about the area model and how powerful it can be across the grade levels. Now, when I'm selecting tools to represent thinking, I like to select tools that are going to give me the biggest bang for the buck. These are tools that are going to be evergreen. Like within the school year, if I'm teaching, say, second grade, and I'm going to be able to use the same tool for addition and subtraction, I'm going to be able to use it for place value. I'm going to be able to use it when we start doing some of our operations and algebraic thinking standards, and even moving into the measurement standards. I want tools that are going to be able to be evergreen throughout the year so the kids can see these connections. I also want tools that are going to be great to use across the years. Pattern blocks is a great example of that. Pattern blocks would be tools that we use in kindergarten just for basic shapes and putting patterns together and developing spatial reasoning. And then in the middle grades, we can use them for fractions. It's probably my favorite manipulative to use for fractions. And then we can use them again when we start moving into algebra and using them to help us solve for unknowns. So just having tools that are evergreen make it really powerful, and that's one of the reasons I love the area model. I love the area model so much because it's something that really does stand the test of time across the grades. So today, I just want you to jump into the chat box and get started with, how do you already use the area model? And "I don't yet" is a perfectly fine response. So right now it looks like we have, whoops, 143 people in the room. So I'm looking for 143 responses. Again, totally okay if you're not even using them yet, just to say, hey, I'm not using them yet. So we have lots of multiplication and division. We have counting, number sense, distributive property. Yes, solving equations. So across the grade levels, we're seeing a nice representation here from addition, early addition, all the way up through polynomials. Mhm. So that area model gets a lot of play as we go across the grade levels. And remember, knowing where it's going helps us teach better in the younger grades, and knowing where it's come from helps us in the upper grades be able to fill in gaps and also help the kids make connections directly to things that they've done in the past. So thank you for sharing the ways that you're using this, even within 20. I see the 10 frame in there. And thank you for the vulnerability for those of you who aren't using them yet. Hopefully, you're going to see something here in the next few minutes that you're going to want to take with you. So, first off, I just want to make this one distinction. When we're talking about area, area is formally introduced somewhere around third grade, usually in most of our state standards frameworks. I'm not sure about the Canadian standards frameworks, but it's usually somewhere around third grade. And the important thing to know is that when we're talking about area, we're talking about covering a shape, a two-dimensional area, two-dimensional shape with square units, no gaps and no overlaps. So that's an important thing to keep in mind when we're talking about area, because there's this thing called the array that we use a lot in the earlier grades. And arrays are when we are looking at placing objects into rows that have equal numbers of items. The rows and the columns are all lined up. And so arrays can approximate area because they have the same kind of idea where everything's lined up in rows and columns, but not all arrays are area models, right? So here in this slide that I'm sharing with you right now, you can see over on the left-hand side are just those circles that are pushed together. That is not an area model because it's not square units that are pushed together with no gaps and no overlaps. On the far right, you see an open array, right? Which we often use, usually like somewhere in third grade, we start using the open array, and it goes all the way up into high school, where we assign units for the dimensions of the shape, and then the students have to figure out how many square units would cover that shape with no gaps and no overlaps. And then right here in the middle, I have a picture of something that fits into both categories, right? So this is if I was creating this rectangle with square units, here you can see all of the squares with no gaps and no overlaps. So in that sense, it kind of is like an array, right? So you have these objects that you put together into equal rows with everything lined up. But because it's a square, because they're all squares with no gaps and no overlaps, it would also be considered an area model. Is this super important for us to distinguish with our kids? Not necessarily, but I think for us as teachers, it's important for us to be clear on this because area is going to become so important in algebra and geometry. I think it's important for us to have a correct geometric understanding of what area is and what it is not. So I'm not going to make a big deal with the kids, but as a teacher, I want to make sure that I'm using language that is clear and precise so that I don't inadvertently teach a misconception that has to be undone later on in the years. So, as we go through this, you're going to hear me jumping back and forth between all these different representations. So, we'll be talking about physical, visual, symbolic, mostly here, but then also be thinking, how can you help your students verbalize the mathematics that we're doing? And then also always going back to contextual. When you're doing something that's more abstract in nature, how can you bring it back to making it conceptual or contextual for your students? And how can you invite them to make it contextual as well? We're today going to mostly live in the physical world of just talking about how these arrays fit together, but keep that in the back of your mind that you want to be able to have the kids connect verbal and contextual representations. So at this point, I'm going to switch over to Brainingcamp, and we're going to just start by talking about the 10 frame. So that was listed by a lot of you in the chat box, and usually when I hear about the 10 frame, I'm usually hearing about that from kindergarten, pre-K, kindergarten, first grade, maybe some second grade teachers. It often doesn't have a life much beyond that because typically a 10 frame, it's just an array that has two rows of five. And we use it for early counting. We use it for beginning addition and subtraction within 10 and within 20. And the kids literally just take these objects and put them into the 10 frame. So here I'm just using the square tiles. Those objects could have been circles, they could have been teddy bears. You already heard my counters. It could be any counters. You already heard my counters lecture. So here's the distinction I want to make right here is that when we have a 10 frame, the 10 frame itself is indeed an area model, right? It has squares that are touching with no gaps and no overlaps. It really helps our kids lean into this notion of a benchmark of 5 and a benchmark of 10 because of the way it's arranged. If you look above, however, at how those counters are arranged, they are more in an array than they are in an area model. Does that make sense? And so again, I just want to make sure that we're being clear that we're calling things what they really are. So when I use square tiles with students, it is simple to be able to create an area model with them just by kind of pushing them together. But if we went back to if I was using the two color counters, if I was using circles, or if I was using teddy bears or any other shape, it's really an array as opposed to an area model. But then in the early grades, we use this particular model to help our kids with a lot of different ideas, right? Like maybe even and odd. I can see here that 10 is even because every counter has a pair. I can count by twos. Later on, we're going to talk about divisible by two. But with our youngest learners, we just talk about how 9 is not even because it can't be matched into twos, right? It doesn't count by twos. 8 is even because it can be counted by twos. 7 is odd because you have an odd man out. So we can use this 10 frame, use this particular area model for a lot of beginning math ideas. So that is the first idea I wanted to share with you. And then as we start moving up into like second grade, third grade, we start talking more about an area model that looks like this, right? We start talking about having these grids. In most of the state standards frameworks, our second graders, second grade-ish, are talking about repeated addition. And so this would be six threes, 3 plus 3 plus 3 plus 3 plus 3 plus 3, right? Or 6 plus 6 plus 6 if we're looking at the rows. It could also, as we shift into starting to talk about multiplication, we use this area model to help us with understanding multiplication. So here I have 6 times 3, and the kids, they can count all of those squares to see that there's 18 square units, and they can see that both of those have 18 square units. And you can see because it's tipped 90 degrees, that's sort of the idea of the commutative property, right? Now there are other models that I use to show the commutative property, but this is one that you can do with the area model just to show that 6 times 3, 6 rows of 3 and 3 rows of 6 both equal 18, but they're configured a little bit differently. But there was something that I saw over or a little bit earlier in the chat box that there were some of you who use this for the distributive property, which I know also in a lot of our state standards frameworks, somewhere around third grade, we start talking about how if you don't know 6 times 3, you can actually use what you do know to help you. For example, if I just split this up right here and I take 6 times 3 and I take that 6 and I decompose that 6 into 1 and 5. Here I can see that I have 1 row of 3, and then down here I have 5 rows of 3. So then I can see that here 1 times 3 is 3, and 5 times 3 is 15, and 15 and 3, that gives me the grand total of 18, right? So we can just split that up, break it apart. Now I could break it up in different ways. If I go over here to the other model I have here, I might have said, you know what, I could take that 6 and I could decompose it into 3 and 3. So if I just split this up right here, I can see that 3 times 3 is 9 on this side, and 3 times 3 is 9 on this side, and together that also equals 18. So I can split this up in a lot of different ways to show that it's 18. But let me show you something that's really kind of cool with Brainingcamp that I've been playing with here. Is they also have this manipulative. I want to show you this tool. These are the Cuisenaire rods, which you may or may not be familiar with. Cuisenaire rods, if I hold up my physical ones, they're just rods that each represent different quantities. Like here we have 10, the blue is 9, the brown is 8, the black is 7. Up at the top, I have 1, 2. So each one of these represents one amount. So what I did right here with my array is I just started thinking, you know what I could do, and maybe this would help some kids to connect this idea with the grid, where at first I was splitting this up to show if I split that up into 1 row and 5 rows, I could show, 1 times 3 is 3, 5 times 3 is 15. Maybe I could do that right here with the Cuisenaire rod. You can say I pulled out 6 rows of 3. And if I just split this up, I can have 1 row of 3 and 5 rows of 3 to give me 18. Now, there's something really powerful in this visual. Up here with the grid paper, we I know I'm calling it paper, that's just what it is in my head. But with the the grid model up there, the kids can still count, right? So that's kind of the difference between additive thinking and multiplicative thinking is here they can still count all the squares. Whereas down here, now I'm asking the kids to unitize. I'm asking them to think in units of 3. And that pushes their thinking a little bit more. Now, with Brainingcamp, I can actually click on unit lines and those unit lines show up. So I can go back to a counting model, but I also want to push the kids into unitizing and thinking in units of 3. Make sense? Something else I could do is I actually brought out 3 columns of 6 as well, because I could leave the 6 intact and I could decompose the 3 into 1 and 2. So here I could have 1 column of 6 and 2 columns of 6, and that plays out just like this here. So here I have 1 column of 6 is 6, 2 columns of 6 is 12, 6 and 12 is 18. So again, I can have the unitizing view where the kids aren't counting by ones, they're actually thinking in multiplicative units, or I can go back and add those grid lines. So, and again, I could do the same thing right over here where I could, when I was splitting that 6 into 3 and 3. Again, I could just split it right there. So I have 3 times 3 is 9 and 3 times 3 is 9. I can do the same thing right here where I can just split it up. Make sense? So you can do it with the grid, you could do it with the Cuisinart rods, you could have the physical Cuisinart rods, and the students are building this up. Again, you want them to be making all of these connections between the physical, the visual, the symbols, writing the numbers into those areas, and then talking about it and contextualizing it. So I've been talking for a while now. I want to give you all a chance to try this out for yourself. So guys, if you could put, oh, the share code is already in the chat box. So take that share code, go into Brainingcamp and try this out. You'll get my screen, just go all the way over to the right, and you might even want to enlarge it a little bit so you're not seeing those other ones I was working on. But just take a moment and play with that and see if you can pull out some of the Cuisinart rods, see if you can practice splitting these up into different amounts. And as you're doing that, I'd really love to see what you're doing. So this is like one of those awkward moments where everyone's playing, and I want you to have a moment to play with this. So as you're in there, play with the Cuisinart rods, play with the model, that the area model that I have here. And then also when you're done, if you wouldn't mind sharing it with me, all you have to do is go up in the upper right-hand corner, click on share, copy image, and you can paste it right into the chat box. So please let me see. Let me see. I can paste that right into the chat box right now. I thought I could anyway. Let's try that again. Maybe it doesn't like to do it when I have Zoom on. It's not going to let me do it. But yeah, let me see what you're doing. And if that doesn't work for you, just go into the chat box and just share. What are you thinking? What are you thinking about this model? What's an aha that you had just now or a good reminder? What are you noticing? What are you curious about? So if you're not playing, you can at least type in the chat box and let me know, what are you thinking about what you've just seen and heard? Rebecca, you're right. It really does make decomposing come alive, right? Which was the goal of this workshop. We want all of the kids to be able to see the math they're learning and for us to see the math that we're teaching and being able to like draw it out. Like sometimes I'll actually have these grids cut out. The kids will have grid paper that they're working with, and they can color in the different sections. There's something really powerful, though, about seeing that representation right next to either the virtual or the physical manipulatives. So they can just see how they're pulling these apart. And I think that idea of additive thinking, where I can still count, versus multiplicative thinking, where I'm starting to unitize, is a really important idea. Um, That is a great question, Bonnie. I'm going to let one of the guys answer that question for you in terms of, is there any way to make the unit lines in the array frame the same unit? So, and Mark, you are so right about the commutative property. That's if I could do a whole session just on the properties of
Mhm.
operations, right?
And Bonnie, that is a really good question about getting the array frame. The array frame naturally is just a little bit larger than the actual Cuisinart rods, just so there's room for them to fit in there. One thing you could do potentially, like if you're trying to make an array for 7 times 4, you could drag out the gray 7 rod and turn off the fill and kind of create a template that your students could drag the Cuisinart rods in to try and fill. But there isn't a way to get the array frame exactly the same size. Good question.
So yeah, thanks for that. And Jeff, thanks for the great answer. I was trying to do that myself. But I decided it was okay for me as long as they were in 2 different areas. I was okay with them being slightly different. Um, so yeah, the next thing I'd like to do is I'm just waiting. I should pause to see if there's anybody else who has a comment. And I'm pretty good at monitoring that chat box while we continue. So if you have a follow-up question or a follow-up comment, please feel free to put it in there. I'm still monitoring that as I continue to move forward. So the next screen that I have for you is moving into using this area model for multiplication and division. Specifically, we're going to talk about multiplication here. The important idea that I really want to point out here is connecting back to what we were just talking about unitizing. It's really important that our kids are unitizing in place value. 10 ones makes a group of 10. Still 10 ones, but it makes a group of 10. And that when you have 10 tens, it makes a group of 100. Still 100 ones, but one group of 100. And so that language is really important. For those of you who've ever seen me talk about this manipulative, which is KP 10 frame tiles, um, this is one way to help kids start making that idea, that unitizing idea. We want them to be able to do that with the base 10 pieces as well. And so what I have here is 12 times 16. And when we talk about multiplication, just like we saw with single digit multiplication, multi-digit multiplication, when you multiply two numbers together in an area model, it always makes a rectangle. And so here I have this frame set up that shows 12 times 16. So I'm going to be creating 12 rows of 16, quite literally. So the first stage that I often try to do with the kids is I just want them to see that we're literally making 12 rows of 16. Right. And often we don't back up the train far enough when we start talking about the area model and we start right away with multiplying 10 times 10 and showing the 100, which I'll get to here in just a second. But the first thing I want the kids to see is we literally are creating 12 rows of 16. Right. So there I have 12 rows of 16. Down at the bottom, you can see that's the 192. But then we can start talking about how there actually were some shortcut ways we could have done this. Like when we were first starting, we saw that we had 10 times 10. And if we decompose the 16 into 10 plus 6, and we decompose the 12 into 10 plus 2, we can use place value to help us start thinking about multiplication. And this is going to lead right into what becomes the standard algorithm later on. So instead of doing 16 plus 16 plus 16 plus 16, that's additive thinking, I really want to start thinking about, I want to start thinking multiplicatively. I took one too many. Let me just make a copy of this and put it back down there. And so what I could have done right here is for 10 times 10, I could have just pulled the 100 right there, right? And I could have showed that 10 times 10 is 100 rather than doing 16 plus 16 plus 16 plus 16 plus 16. In fact, I'm just going to take all of this off. Whoops. And I can show now that 10 times 10 makes 100, right? And now I have 6 times 10. So I can literally show that here I have one group of 10, two groups of 10, 3, 4, 5, 6 groups of 10. See the unitizing, the way my language just changed? So here I have a group of 100. I have 6 groups of 10, which is 60. And so that now shows me the first 10 rows of 16, right? If I look all the way across here, I have 16 in every single row, but I still need 2 more rows of 16. So I can simply copy this right here. And here's 11 rows of 16 and 12 rows of 16. And that's how I end up with my 192. I can think about the partial products right here. 10 times 10 was 100. And then I had 10 times 6, which was 60. And then I had 2 times 10, which was the 20. And then I had 2 times 6, which was the 12 down here. And the kids can literally see how when you add those together, you get 192. And as we start sneaking towards that standard algorithm, which in most state standards, somewhere around 5th grade, we explore this in 4th grade, and we move to standard algorithm in 5th grade, we can look at 100 plus 60, those two together 10 times 16 gave me 160. 2 times 16 gave me 32. And those are the two partial products that we see when we start working on the standard algorithm. So this just makes it so visual for our kids. And now I have to stop sharing for a second because I need to make a comment about a really common model we use with our kids. And this really common model is looking at the area model like this. And I have a hard time calling this an area model because you really can't, it's not proportional anymore. You know, right now it's more like we have four equal sections, four equal partial products, and this is really called an open array, right? So I'm careful to call this an open array. I see Adriana calls it the box method. I call it the window panes. So they all have different names. This works just like what we just did, but way too often we start here. This is more like in the middle, somewhere between seeing it proportional and working with the standard algorithm. Somewhere in the middle, we want the kids to be able to see how these things connect. So here I have 10 plus 6 for the 16, 10 plus 2 for the 12, right? And just like we saw on the screen, the 10 times 10 is 100, but it's no longer proportional. The 10 times the 6 is the 60. The 2 times the 10 is the 20. The 2 times the 6 is the 12. But now it's more like a window pane. Now it's more like boxes. This is partial products, is what we often call it, but it's an open array. This isn't really technically the area model because we're not looking at area. We're no longer looking at how many square units fit with no gaps and no overlaps. So does that make sense? Just trying to be precise with the language we use because the language we use matters. And it matters later on when the kids get into new grades and they are hearing it slightly different and they don't necessarily have the foundation that they needed to begin with. So that mirrors what we just did here on the screen. And I wanted you guys to see that. And then as it connects to the standard algorithm, we end up seeing how those partial products end up being 32 and 160. And then we want the kids once again in fifth grade. Yes, the standard might say, or maybe sixth grade or wherever it happens in your state or country, it might say standard algorithm, but you want to connect back to where did this come from? And the area model is such a powerful, powerful way to help kids see that. So I do have one for you to try out, and I think we have just enough time. I'm just going to give you a couple of minutes to play with this. So if the guys would put that back in the chat box for me. And that's a new code, so it's different from the old code. So just put that code in and give this a try. Take a look. I put 13 plus 14. And for me, I usually put 13 along the vertical axis and 14, the second number, along the horizontal axis. It really doesn't matter. But I just like to be consistent for the sake of my kids. So you have two options now. Use that share code to try this out. Or go to the chat box and tell us, what are you thinking? How are you feeling? What are you noticing? What are you wondering? What are the ahas? What are the good reminders? And what are the questions that we're leaving you with right now? So Judy, you are so right. I really like to camp out in mathematical practices 7 and 8 a lot. 7 really talks about that amazing structure that we want to focus in on. And this helps us see the structure. It also helps us see what happens with repeated reasoning, which is practice 8. And then you were talking about math practice 6, which is attending to precision. And the language we use matters, the way we represent these things matters, and the way we have kids connect. Remember back to the Lesh model. The important thing is those connections, the arrows that show how does what I'm representing visibly show up in the numbers? How does what I'm focusing in on with concrete materials show up with a visual model? So we want all of these things to be interconnected. So, oh, and Catherine, yes. I mentioned this really briefly at the beginning that this is really something I want the kids to be able to maneuver. This is not just me. When I was getting my national board certification for the first time, I'm national board certified in early adolescent mathematics. I did some work with the area model with having the kids use tactile physical tools to build out these rectangles with these kits called the Mortensen kits. Some people call them combo kits, multi-sensory kits. They're called all different kinds of things. They're kind of like a cross between the base 10 blocks and the Cuisinart rods. And giving the kids the option to build it out that way, or to build it out on a grid, or to build it out on a screen like this. I will have kids doing all different things interchangeably because they're the ones who need to do this. Okay, so thank you for those of you who are participating. I know some of you are playing along, some of you are going into the chat box. I'm going to shift to the next screen. We're getting close. We have 9 minutes left. We will finish on time. But I wanted to go one more step and show how all this amazing stuff that we're doing in elementary school, in the primary grades, in the middle grades, in middle school, makes its way into algebra and algebraic thinking. Now, I could have chosen something a little bit simpler, little middle school. This works in a lot of different ways, but this one is really profound because of what we've been doing so far. So this, as you can see, is we're going to be multiplying factors here. But this is algebra now, right? So here I have x plus 2. Remember how before I had 12? Let me move back to that. How I had 12 right here. Now it's become x plus 2. And then x plus 6 before I had 10 plus 6 across the top, but now it's x plus 6. It's an unknown. We don't know what it is. So this x right here, it's unknown. We don't know what it is. But we do know that when you have x plus 2 and x plus 6, I have two x's that are going to be multiplied together. Back here with multiplication, it was 10 times 10, and it made a square, right? If it was 3 times 3, it would make a square. If it was 8 times 8, it would make a square. So here it's x times x. So it's going to make a square. In this case, it's x squared because we don't know what the value is, but it's x right here, right? And then I want to be able to show that I have x times 6. So I'm just going to bring out, well, here's 1x, so x times 1, x times 2, x times 3, x times 4, x times 5, x times 6. So now I have 6 x's along here. Does that make sense? So I have x plus 6, x plus 6, x plus 6, x plus 6 going all the way across x number of times. We don't know how many times yet, but it's x number of times. But I need to do that 2 more times. So I can simply copy this and move it down. So there's 1 more time and 2 more times. So now I can see that I have x squared, I have 8 x's, and I have 12 as my constant. So this fits so closely with what we were just doing back here, only here it was with quantities, right? Here we had x squared. In this case, it was 10, so it was 100. Then we had 6 groups of 10, 2 groups of 10, so a total of 8 groups of 10, and then 12 more. So here's what needs to be happening is the way we talk about this in the middle grades and in middle school connects with what we're doing in algebra and pre-algebra. And for those of you who are teaching pre-algebra and algebra, we want to connect back to what the kids did in previous grades. Helping them see these connections makes a difference. We want our kids to be able to see the math. So once again, I made a little play area for you, a little playground. We still have 6 minutes left, so we're good. I want to give you just a couple of minutes to play with this idea. So we can put the share code right here. There it is in the chat box. So you can either play with that or go to the chat box now and tell me, what are you thinking? What are you excited about? What are you curious about? What connections are you making? What questions do you have? So, yes, Rose, this kind of learning is good for all students, including those with special needs. This kind of learning is great for all students, including those who are English learners, right? This kind of learning is good for all students, including those who are in the gifted program. I was doing a lesson not too long ago. It was a fifth grade lesson. We were doing division of decimals. We modeled the whole lesson. It was a very short model. We launched the lesson, I should say. It was like, a 3-minute launch. And then we put the students into groups, and they had the option. You can use manipulatives, you can use grid paper, you can just use whiteboards, you can use whatever tools you want. And 11 of the kids chose to use manipulatives, physical tools. And you know what? Every single one of the students who was enrolled in the gifted program were in that group of 11, choosing to use the manipulatives. So we want kids to be able to make these connections no matter what they're learning. These are learning differences, right? And so we want kids to have access to whatever tools are going to make the most sense to them. In my classroom, if the kids are working, like if we're doing a thinking task and we have the kids in groups of 3, sometimes we'll have somebody who will take a laptop or take a device to their group, and they'll be working on a device using these kinds of tools at the boards. And you don't have to be doing a thinking classroom to do that. When kids are sitting at tables in groups, in pairs, in threes and fours, they can also be using devices. They can be using hands-on tools. They can be using whiteboards. Give them access to all the different tools. That is what's really important. And I am loving all the comments about Brainingcamp in the chat box. And thank you to Mark and Jeff for addressing all of those. So I'm going to let you guys keep going with that. Were there any questions in there for me? I don't.
One question that I was just in the process of responding to, somebody asked about finding the factor track. Kim, would you be able just to show on the bottom left corner where the workspace button is? So just where it says factors there on screen right now, a little bit further to the left.
Oh, yeah, I'm sorry.
Right there. Right. So somebody made the comment during base 10 block. So every single one of our 18 manipulatives have their own unique set of workspaces. So with base 10 blocks and with the algebra tiles, she just chose the factors workspace. So that is how you get the factor track. So great question.
Yeah, that is a great question. I'm glad I could
Mhm.
show that off here. Okay, so I am going to just bring this in for a closing, but everybody here, if you have additional questions, please feel free to put them in the chat box. Also, if one of the guys could put my email address in there, I'm happy to continue the conversation with any of you. My email address is kim@kpmathematics.com. It'll be here in a second in the PowerPoint as well. And you'll see in the slide deck, I have just a screenshot of each of the frames that we just did to remind you. But as we're talking about making these connections within and across the grade levels, one thing that I mentioned is that I think it's so important for us to think about how do we make sure that we use tools that are evergreen, that can show up again and again as we're teaching content throughout the year and across the years. And so for me personally, there's one tool, base 10 blocks were never quite doing it for me. So I decided to invent my own manipulative, which is a groupable manipulative, which helps the kids unitize. 10 ones becomes a group of 10. 100 ones becomes one group of 100. And for this particular tool, it goes all the way from counting to 10 through powers of 10 and solving equations. So that's the tool that I like to use. But I want to encourage you to think about what are the tools that you can use that really do live across the grade levels and within your grade level. Pattern blocks, two color counters, which become integer chips later on, base 10 blocks, which I showed how they translate into using algebra tiles. So be cognizant of how those fit together. And then also, there's some books. If you want to know more about some of these ideas, there's manipulatives books that I co-wrote. The one that we're spotlighting today is Seeing the Math You Teach, which Jeff is also holding up his copy right now. And just let me spotlight that for you a little bit more. Just this book is about 200 pages long, but one thing that we were talking about, and the reason that this webinar came to be, is that this book can give you insights into seeing the math that you teach, and then you can use Brainingcamp to actually create those models. So in the book, these are just a few of the pages that spotlight anything that has to do with the area model. So we start with the 10 frame, we can shift into an area model with multiplication, and compare it to other models, right? That translation is the important part. Getting into single digit multiplication strategies. Here you can see some multi-digit multiplication like we did today, with both arrays and area models. Um, Shifting into division and using that with division. Even working with decimals, multiplying and dividing decimals, shows up really nicely, as well as with fractions. Back to the littles, even and odd numbers show up nicely with an area model, as do factors, common factors, prime numbers, composite numbers, equivalent fractions, multiplying fractions by fractions, decimals by decimals, and all the way up into some of the algebra that we do. So I just wanted to show you that, these two tools really do work nicely together. And also, for those of you who happen to use the building thinking classrooms model that Peter Liljedahl taught us all about, know that these tools often, when I'm working with students, I will have one student take a device to the boards, and they can use a device. They can set it on a desk, on a shelf, on a table. They can sit on the floor. But these tools really do play out nicely, as well as do manipulatives. If you want to know more about that, Peter and I did a webinar for Hand to Mind back in January. And you can go back and watch the replay of that on manipulatives in a thinking classroom. So, guys, that's kind of it. I just would like if you guys wouldn't mind one last time going into the chat box and letting us know what's one thing you heard today that you look forward to using tomorrow or next week or next month. And on that note,